Although urbanists constantly call for reducing transportation-related emissions in city centers, emissions in suburban areas are rarely discussed. Yet the past 20 years of U.S. Census data proves that suburban areas are the population majority and where more than half of new jobs are created, resulting in large amounts of driving. Therefore, reducing transportation-related emissions must take into account the suburbs by finding ways to reduce fossil fuel consumption. This project, PetroMetro, is based on two assumptions. First, suburban driving is automobile-based, and second, reducing driving in the suburbs is not realistic. Thus, is it possible to replace 100% of fossil fuel used for suburban driving with a renewable alternative? To answer this question, we chose to study metropolitan Chicago because its population of 9.5 million makes it comparable to many global cities and tests the upper limits of resources needed for replacing fossil fuels. It has a large and robust suburban fabric, it is near major ethanol production facilities, and has a news center dedicated to electric vehicle research. Compared to surrounding suburban counties, Cook County, in yellow, which contains the city core, has the highest population and population density, number of single-family homes, and paved roads. While the average amount of driving per day by each household is actually higher in the suburban counties than in Cook County, the total vehicle miles traveled, or VMT, by people in the city core is not much different than the VMT generated by the suburbs. One would expect to find higher VMT in the suburban counties, but the central urban county has nearly as much total VMT as the suburban areas combined, which is a surprising discovery given conventional assumptions about dense urban areas promoting less driving. Thus, to replace all automobile fossil fuel consumption in Chicago suburban households, a new energy infrastructure would have to provide fuel for 62.6 million vehicle miles traveled. This totals 3.1 million gallons of gasoline per day, which in energy terms equals 1,300 gas stations or 2 500-megawatt coal-fired power plants or 10 square miles of solar photovoltaic panels. Next, we investigated the landscape impacts of renewable energy sources when scaled to provide enough energy for 62.6 million VMT. We found that producing enough corn ethanol to meet energy demands would consume 4,400 square miles. This would mean covering the entire ring of 7 suburban counties in cornfields. But algae ethanol could be more viable. Compared to corn, it is projected to produce 5 to 10 times more ethanol per acre, on 1/5 to 1/10 the land area, and with less water and energy than corn. Plus, it can be produced on marginal or unused lands. Chicago's suburbs contain enough large fallow farms to accommodate algae biofuel production on the scale required to replace suburban fossil fuel consumption, which is about 890 square miles. Retrofitted vacant big box stores could serve as processing, collection, and distribution points. Finally, we investigated the potential of solar photovoltaic units to provide energy for electric vehicles. Where could suburban areas accommodate solar photovoltaics? Interstate right-of-ways provide an easy retrofit, but only yield 48% of energy needs. If big box stores and their parking lots were added to interstate right-of-ways, the extra 4 square miles would meet 98% of energy needs. If all existing park space in Cook County was retrofitted with solar panels, this would yield 128% of energy needs for driving. Another solution is to make use of redundant elements in the suburbs to create a decentralized energy infrastructure. For example, outfitting all household driveways in Chicago with solar photovoltaic units would yield 160% of energy needs. To compare these alternatives, we created a matrix plotting each alternative as distributed versus centralized and whether it provides a deficit or surplus of energy. Driveway solar is the most distributed alternative with the maximum energy surplus, removing 6.6 million tons of carbon from the atmosphere annually. There are many design opportunities for a new solar suburbia. Driveway solar could match a distributed need with a distributed infrastructure, minimizing the need for new generation capacity and large government infrastructural spending. New neighborhood districts could organize around energy needs, setting in motion a desperately needed distributed energy market where competition involves new energy and development hybrids, landscape retrofits, and new suburban models. PetroMetro was chosen by an international jury to be exhibited at the 2014 International Architecture Biennale in Rotterdam under the category of Energy and Metabolism of the City.